Hi and welcome to this clip looking at a levelled response question on a very common topic pairing in OCR exams, alcohols and spectroscopy. So looking at the question, we've got a series of alcohols from earlier on in the question, but this section wants us to do a little bit of analysis of some information to do with their oxidation. So it says compound X is one of those alcohols, so you've got the structures from which to make your choice. And the student refluxes compound X with acidified potassium dichromate 6 as an oxidizing agent, and a pure sample of the organic product is obtained from the resulting mixture. They provided you with the mass spectrum and the IR spectrum of that product. So having a look at the first bit of information, refluxing an alcohol in the presence of an oxidizing agent would lead to either a carboxylic acid if the alcohol was primary, or a ketone if it was secondary. So that means that your product, Y, can't be an aldehyde because that would be produced from distillation and not refluxing. The base peak of the mass spectrum is MZ43 and represents the most likely fragment of form. We can come back to this a little bit later. The M plus peak represents the MR of the molecule. So in this case we've got an MZ of 86, so therefore the MR is 86 grams per mole. The very narrow peak at 2,500 to 3,300 centimeters minus 1 suggests that we haven't got a carboxylic acid because it's not broad enough. So that might suggest that alcohol X is not primary, but secondary. The significant peak at 1,630 to 1,820 centimeters minus 1 shows us that there's the presence of a C double bond O, which again goes with the possibility of Y being a ketone. There's no major peak at 1,000 to 1,300 centimeters to minus 1 if we discount the fingerprint region, so that means there's no C single bond O either. Again, that points very strongly to a ketone. So let's look at what the question wants us to do. We're to identify compound X and product Y, write an equation for the formation of product Y from compound X, and make clear how our conclusions are linked to the evidence. So let's structure the question first, because we have several different pieces of evidence to talk about, and then we can put our conclusions at the bottom. So we've already said that refluxing alcohol with acidified dichromate would give a carboxylic acid from a primary, or a ketone from a secondary alcohol. We've mentioned in passing that the MR of the compound is 86 grams per mole. So therefore we can say compound Y can't be derived from alcohols A, B or D, A and D being primary and B being tertiary. So the base peak is MZ43, so that could represent CH3CH, CH3+. At this point I'm just literally coming up with some possibilities, not necessarily landing on any particular alcohol, but just trying to think of carbon-based fragments that might end up at 43 grams per mole. So if we focus on alcohol E, you can see that there might be a fragment on the left-hand side of the molecule there, next to where they printed the letter E, that could be CH3CH, CH3+. So if we list all of the different peaks in the IR spec that we've talked about or had to think about earlier, and then we can say something about them. The most important thing to say is the presence of the C double bond O. You could also mention the absence of OH carboxylic acid and the absence of C single bond O as well. So now we can state that X could be alcohol E, as the ketone that's derived from this would still satisfy the IR evidence, plus give a fragment of CH3, CH, CH3+. So the structural formula of Y is CH32 CHCOCH3, and the equation is, as you can see, at the bottom of the screen. So don't forget that there's a water molecule produced as well, that's important, and only one oxidizing agent, oxygen atom, is needed, so one square bracket with O inside. Okay, so hopefully this is a useful look at one way in which this question could be answered. It's not the only way, and I'm not trying to say it's perfect either, but like I said, hopefully it's been of use. So thanks for listening. Until next time, see you soon.